विद्यार्थी मित्रांनो, आपण 11वी मधला शेवटचा जो टॉपिक आहे सेमीकंडक्टर तो बघणार आहोत. या टॉपिकमध्ये नीटसाठी किमान 2 प्रश्न विचारले जातात आणि त्याच्याचमुळे आपण या टॉपिकचा याच्यामध्ये अभ्यास करणार आहोत. व्हॉट इज मीन बाय सेमीकंडक्टर? फर्स्ट ऑफ ऑल वी हॅव टू सी semiconductor means the electrical conductivity between conductor and insulator are known as a semiconductor. Example: silicon, germanium and carbon. Now according to the energy band theory, again all the substances can be classified into 3 groups, 3 types according to their energy band level diagram. They are as follows. One is a conductor, another one is insulator, and third one is semiconductor. According to energy band diagram, the energy levels or energy of electrons in the valence band or outermost electrons in the band, they are known as valence band. If valence band and conduction band overlap with one another, or there is no any forbidden energy gap between valence band and conduction band, those materials or those solids are known as conductors. Example: copper, aluminum, silver, gold, etc. In case of insulator, the valence band is partially or totally filled and conduction band is empty, and there is a very large gap between conduction band and valence band. It is about 3 electron volt. That type of solids are known as insulators. Example: wood, plastic, mica, etc. The another type of solids having valence band is completely or partially filled, but the conduction band is empty and there is a very small gap between valence band and conduction band. That type of solids are known as, that is 1 electron volt or less than 1 electron volt. That type of solids are known as semiconductors. Example: silicon, germanium, carbon, etc. Now after that we have to see the semiconductor. How many types of semiconductors are there? Now there are 2 types of semiconductors are there. One is intrinsic semiconductor. Semiconductors are of 2 types: intrinsic semiconductor or pure semiconductor. Intrinsic, or it is also known as a pure semiconductor, and another one is extrinsic, or it is known as impure semiconductor. Impure semiconductor. Now we have to consider a silicon crystal. What is meant by silicon crystal? The number of atoms of silicon, they are orderly arranged in a manner, such a manner that this is known as silicon crystal. We know that the atomic number of silicon is 14. In the outermost orbit there are 4 electrons. Each electron of silicon shares with neighboring electron of silicon and forms 4 covalent bonds. These bonds are very strong bonds. At room temperature or absolute zero temperature, there is no free electron for the conduction, and therefore we have to say that a pure conductor or intrinsic pure conductor at room temperature or absolute zero temperature, he behave as a bad conductor of electricity. Why we have to say that as a bad conductor? Because there is no free electron for the conduction is available in the crystal. To increase the conductivity of such a semiconductor, now we have to increase the temperature. Because of increasing the temperature, there will be the thermal vibration in the crystal and bond can break. The electrons are free for conduction and electrical conductivity increases. Such a type of semiconductor is known as intrinsic semiconductor, but usually we have to not use such a type of semiconductor. Now we have to use which are very important in your life, that is in the electronics, that is extrinsic semiconductor. To form extrinsic semiconductor or impure semiconductor, some impurity can be added in it, and the addition of impurity is known as doping, and doped semiconductor is known as extrinsic semiconductor. Now there are two types of doping, and hence there are two types of semiconductors can be formed, that is one is a p type, another one is n type. When the addition of impurity belongs to third group of periodic table having 3 free electrons like aluminum, gallium, indium, etc., then 3 electrons of aluminum shares with neighboring 3 electrons of silicon and forms a 3 covalent bond. In the fourth bond there is an absence of electron, or we have to say that is a missing of electron, which creates a hole in the crystal. Holes are positively charged particles, and when we have to apply the potential difference, the holes can be moved and the electrical conductivity can be increases due to positively charged particles. The electrical conductivity increases due to positively charged particles. Therefore, such a type of semiconductor is known as p-type semiconductor. The impurity added in pure semiconductor, that is aluminum, indium, gallium, accepts electron from the neighboring. Therefore, such impurities are known as acceptor impurities. Such impurities are known as acceptor impurities. Now, to form n-type semiconductor, the addition of impurity belonging to fifth group of periodic table having 5 free electrons like arsenic, antimony, bismuth, phosphorus, etc. 4 electrons of antimony or arsenic shares with neighboring 4 electrons of silicon and forms a 4 covalent bond. The 5th electron is free in the crystal. When we have to apply the potential difference, the electron moves, that is because of the motion of negatively charged particles, that is electron, the electrical conductivity increases. Therefore, such a type of semiconductor is known as n-type semiconductor. These impurities donate electron for the conduction. Therefore, such impurities are known as a donor impurity. Such a impurity is known as donor impurity. Now, we have to see n-type as well as p-type. In case of n-type and p-type, there are many MCQs are asked, up to 10 MCQs are asked in this. Which impurity is added to form a p-type semiconductor, which impurity is added to form a n-type semiconductor, or how many covalent bonds are produced in the p-type semiconductor, how many covalent bonds are produced in n-type semiconductor. The impurity added in N type are known as acceptor impurity. Impurity added in P type is known as acceptor impurity, and N type is known as a donor impurity. Now after that we have to see the p-n junction. Now we have to see p-n junction diode. How the p-n junction will be formed? We know that p-type semiconducting material is rich in holes. That is positively charged particles. And N-type semiconductors are rich in electrons. To form p-n junction, to see here, p-type semiconductor material is joined with N-type semiconducting material. The junction is known as a p-n junction. We know that in P there are large number of holes, means the majority charge carriers in p-type semiconducting material are holes, and minority charge carriers are electrons. In case of N-type semiconductor, the majority charge carriers are electrons and minority charge carriers are holes. When the junction is formed by migration of holes and electrons, some of the electrons from the N region crosses the junction and stay near the junction in P side. Some of the holes from the P region, they crosses the junction and stay in the N region near the junction. The layer formed by holes and electrons near the junction is known as a depletion layer, and the potential of this layer is known as a barrier potential. Barrier potential. It is about 0.7 volt for silicon and 0.3 volt for germanium. And the width of the depletion layer is about 25 micrometer. 25 micrometer. After that we have to see what is meant by biasing. Biasing means the connection of battery to the p-n junction is known as a biasing. There are again two types of biasings are there. One is forward biasing and another one is reverse biasing. In case of forward biasing, what happens when the positive side, that is a P side of junction, is connected to positive terminal of the battery, and N side, that is a negative, is connected to negative terminal of the battery. In this case, what happens? Both holes and electrons move crosses the junction continuously. Holes and electrons both crosses the junction. The width of the depletion layer goes on decreasing, and continuously the current will be flowing through the junction diode. Hence, diode can be used in electrical circuit only in a forward bias. In case of reverse bias, that is a P side of the junction, that is positive of the p-n junction is connected to negative terminal of the battery, and N side, that is negative side of the p-n junction is connected to positive terminal of the battery. In this case, both electrons and holes move away from the junction. Both holes and electrons move away from the junction. The width of the depletion layer goes on increasing. there will be no single electron or no single hole can cross the junction. Therefore, the electric current in this case is 0. Hence, the diode cannot, PN junction cannot be used in the circuit in a reverse bias. After that, we have to see what are the uses of these semiconductor diodes in electronic instruments. That is, the PN junction diode is very important in case of electronics instruments such as computer, laptop, cell phone, and many devices can be done from this. That is a photodiode, solar diode, light emitting diode, transistor, switches, ICs, etc. These are the number of applications of semiconductor diodes or semiconductor theory in your daily life. And thank you, student. You will watch this video and give us the semiconductor. Dear student, you will share, and if you like this video, then share, subscribe, and do it comment. Thank you.